thank you for Hai for introductions. I studied AI many years ago. I was at Stanford, actually went to Stanford many years ago, and the time I studied AI when I was there. And after that, AI was not very particularly useful because probably many of you remember or recall that where AI was not enough compute, right? Not enough power for making AI useful, except in one area, which is in computer gaming. So I spent almost 20 years bringing AI technology for make computer games. That's in fact, that's how NVIDIA got started, was in selling video card to game companies. And about 10 years ago, realizing how important computer science is or how important AI is at the time, AI started about 10 years ago, AI becoming very, very definitely, much more noticeable and applicable. So I kind of went back, I left the industry and focused my time on teaching K to 12 students, focused on computer science. So the talk today, I would do a quick summary what the talk was last time, which is focused on how generative AI, what generative AI is and how does it impact education, right? So many of you are parents. Well, I think all of you are parents, maybe some students. So probably in your mind is how, with all this thing happening in AI, what should I do, or how should I help my kid to better prepare for the future? So I kind of quickly summarize that talk from last time. But the focus for today's talk is, well, understanding how important AI is. How do you learn about AI? What exactly you should learn, and then what's the best way to learn that? I think that's really the focus for today. So there's no really, hopefully by now, not many of you still have a question, whether AI is here to stay or how important AI is. I believe, lucky for me, I experienced at three different times, the three different disrupted technologies. So AI, obviously, I consider that 2022 when ChatGPT was announced, it really brought AI to the forefront and become the next disruptive technology. So you can compare that obviously to the iPhone, and you can also compare that to Netscape, when Netscape really brought the internet to everyone. So just like OpenAI brought AI to everyone. So what does that mean? What does that mean that, what does exactly, AI has been around for a long time. Why suddenly ChatGPT brought AI, to us in a significant way that changed everything? It really came from three different things. The first is a G, right? So generative AI, well, if in Chinese it's called 生成式 AI, 人工智能. So before ChatGPT, people are using AI, right? Using AI, but as AI is using to recognizing things, you search things, you use AI to compute something. But AI you never really use AI in a way that help you to generate pictures, help you generate essays. So the ability to generate instead of just to recognize makes it much more useful, right? So it opens up many, many new opportunities. So that's the first impact. The second, is the P. So the P in GPT is for pre-training, right? Pre-trained. So the model is pre-trained. That means now you don't have to spend a lot of money to train the model from scratch. It provides you the baseline, in fact, very powerful baseline. Now you can use it, right? But the other P, which is not the P in the ChatGPT, is prompts. With prompts, Chinese called 提示语, right? With prompts, now everyone can be a programmer, right? What does that mean? You no longer have to learn Python or C++ to be able to talk to the computer. You can talk to the computer in English. So basically, if you put all this thing together, what it means that it makes AI much more accessible and lower the barrier in entry. So because the model's pre-trained, you don't have to spend a lot of money training it. And with the prompt engineering, you can actually you can just talk to it in English and be able to interact with the AI. So with all this together, so we can see that obviously AI been there's AI been around.
你那个看到真的是很好嘞， 就是在外面，那就在里头玩有哈。
Can you mute yourself,
这
please?
叫什么？是名字的。
Yeah, so remember to mute yourself when you come in. So, but we start seeing adoption of AI has been accelerated in the last couple of years, right, since ChatGPT. And today, I think it's fair to say there's probably not many large industries not impacted by AI. So, and Andrew Ng, a professor at Stanford at the time, make this phrase AI is the new electricity. So this is actually several years ago before ChatGPT, but I think now today it's definitely true, right? If you don't believe in it a few years ago, you should believe it now. But what does that mean? What does it mean by AI is a new electricity? Well, number one is pervasive, right? It's everywhere. It's just like electricity. You don't really notice it, right? Well, you notice it at night, but you don't really pay attention. Oh, there's electricity, but that means it's everywhere, right? And it's transformative. Electricity, it really transformed everything, right? So today, just the fact that you can't imagine living without electricity, but people lived without electricity many, many years ago, right? So it actually changed everything. But the last point is really what I want to focus on. We're still in early innings. That means we're still very, very in the very, very beginning, right? So some student or some parent asks, "Oh, are we too late?" Well, if you're a student now, right, whether you're in elementary school, middle school, high school, or even in college, you're at the right time. Because we're still early, and the fact that, or your children's still early, the fact that you're paying attention to this, that means you're aware of it. So just like if you're born in the 90s, or not born in the 90s, if you're a student in the 90s, you'll catch an internet wave, right? The internet revolution. So if you're a student today, hopefully you're well positioned to catch this AI wave. So the impact, so what does that mean, right? So now it will change everything, but what does that mean exactly? Well, it will change, this is actually McKinsey had a report about AI, the impact before ChatGPT. It predicted that 800 million jobs would be affected, would be displaced, right? So they didn't say that it will be lost, right? Some of the job will be lost, some of the job will be changed. I think that's probably the way to look at it, right? That the nature of what you're doing would be changed drastically because of AI. So obviously, a lot of redundant, repetitive job would be replaced, right, by AI. But people always worry, oh, then will I be no job? No, your job will be changed. You'll be working on different things. So if you're still doing the old things, right, you're still doing repetitive things, well, obviously you have no job. But the hope is that you would adapt to this new environment so that you'll be working on the new job that is created with the AI as a tool to help you, right? So obviously change if the workforce get changed, then obviously it's education about preparing the student for this workforce, right? So that would also change. So I think the most significant impact of AI is in fact in education. Unfortunately, many schools, whether it is in US or in China, I was in India, it's still the same, right? So they still are focusing on what I call preparing students for, what I call the USB style, right? So it's about knowledge, about memorizing things. But in fact, for AI, in the age of AI, skills becoming much more important. Creativity and problem solving, particular problem solving with technology, become much more significant. So how, just dig a little bit deeper, right? So what does that mean for school? Schools today, a lot of the time you spend time learning how to answer a question, which is still important, right? You learn how to answer a question, you have to think about it, you do reasoning. But a more important skill, you need to learn how to ask questions, right? Asking new questions, asking questions not being asked before, it's the key for innovation, and that become a much more important skill than before. And second, which is I think the focus of today, remember to mute yourself if you come in. So the other thing is really learning how to use technologies. Unfortunately, if you look at school today, right? So, maybe some of you already learned, obviously many of you have computers. And maybe you learn how to you program, right? But not many subjects in school you're learning today allow you to actually use technology to solve problems. For example, you take physics class, right? Um, well, hopefully, if the class, if you're in the right environment, you'll learn how to use computer to help you solve physics problem, how you do experiment, how you discover, right? So those are two, I believe those are two important thing for the school going forward is how do you learn to use technology? How do you learn to ask questions? When you ask a new question, then how do you use technology, AI, to solve those new questions, right? So finally, this is kind of the end of the last talk. AI becoming the new literacy. So the reason for that, because we'll coexist with AI. So obviously, for many centuries, humans are the only intelligent thing, right? So as long as we know how to read and talk and so on, we can communicate with other human. But going forward, besides human, you have another type of intelligence, the artificial intelligence. So you need to talk to this other intelligence, right? So then, just like you talk to a foreigner, right? Someone from France, someone from other country, you need to understand him. Same thing. If you want AI to help you, you want to have a deeper level of communications and collaboration with AI, you need to understand AI. So that's why learning AI becoming as important as you learn math and learn language, right? So the question then is what exactly is learning AI, right? So, I have many conversations even with the school principal, with parents, and they all, in fact, many countries, right, in Japan, in China, and Korea, UK, probably in the US, some of the country actually mandated, Japan and Korea mandated the school to teach AI, teach computer science, but many principals say, well, what exactly it is? Same thing, many parents have the same questions, right? So, 50 years ago, the focus on 3 R's, right? So, but today, um, actually, when we start in the last 20 years, a lot more people talking about the 4 C's, right? So critical thinking, communications, creative, being a creator, critical thinkers, and collaborators, right? The 4 C's. But as AI, as computer science become more and more pervasive, there comes the 5th C, right? The 5th C. But there's some misunderstanding, unfortunately, what this 5th C is. A lot of parents and a lot of even, schools think about, when they think about the computer science, right? They think about computer science, AI is learning a programming language, right? In fact, a lot of coding school exists today, everywhere, online, offline. They perpetuate this belief. So in fact, if you look at, um, here I have a little, actually, this is an email I clipped from some parents sent to me. So I got an email from my parents, about a student. So I said, what have he done so far? Well, he know all the languages. He took Python, he took Java, and he took C++. But at the end, I actually talked to this student. He actually doesn't really know why he learned all those languages. And he doesn't really, so because the parent wanted him to do competition, and he doesn't really know how to use those languages. And but on the other hand, he know all those languages. So the key, the language, it's just a language. It's a tool for you to communicate with the computer, right? Just like, if you learn Japanese, would be allows you to talk to someone from Japan. It's a tool. Now, the most important thing is the content of the communication. What do you want to tell the computer, right? How do you want, what's the content of communication? What do you want to talk to this Japanese friend, right? The language is only a tool that allows you to have communication. So, now if you come back to ChatGPT, in fact, now with a prompt engineering, you don't even need to learn a language, right? C++, you can actually talk in English. I'm not saying the language is not important, but if you think, okay, learning computer science about learning language, that's definitely the wrong understanding. So the fifth C, right? So we think of this become important is not for coding. In fact, the fifth C is what we call computational thinking. So what exactly is computational thinking? There's a definition of it, right? So decomposition, abstraction, all those stuff. But I just want to but to some parents like, well, what is problem decomposition? What's pattern recognition? So in fact, I want to kind of simplify a little bit, right? So from that, there's really three unique aspects of computational thinking. The first one, in fact, probably the most important one, is you need to learn how to teach. At school, you learn how to learn, right? You're a student. But in fact, if you think about what a computer scientist do, what computer science teach, they actually teach, they teach what you know, right? If you're a programmer, what do? You teach what you know to the computer. So it's your ability to teach what you know. The second is your ability to when you teach somebody to do something, obviously you don't want to teach just one case, right? You want to teach the whole class, right? The whole class of problem, right? So ability to generalize. In fact, if so I'm going to go into a little bit detail. And then finally, the last point is how do you leverage the power computer, right? Much faster, much larger memory than you and I. How do you leverage that to actually solve harder problem that even human cannot do? So I'm going to focus mostly on the first two part, and then I will actually give you an example of that. And then the third part, is actually more technical. I'll leave that to in the future, and maybe there's another talk. So teaching, right? Teaching what you know. Traditional subject you learn at school, you're the learner, right? You're the learner. So the teacher tell you what to do, and you just learn, and then you do it, right? But in computational problem solving, you are the teacher. You need to teach what you know to the computer, right? So I'm going to give you an example of a simple example to illustrate this point and the next point. Now, the other thing is that you need to learn how to discover or how to recognize patterns, right? Or how to generalize. Again, in school, most of the subject you learn, you're giving a formula, right? So, you learn physics, F equal to ma, you learn that. But you seldom delve into, well, how did Newton come up with this thing called F equal to ma, right? So again, there's many, like trigonometry, geometry, physics, a lot of math. So that type of reasoning is known as deductive, right? You're giving a formula, you plug some number in, and you get another thing, you combine some formula, you get to the next thing, right? Now, computational thinking is actually the reverse. You're giving a lot of cases, right? So it's almost like a detective, right? You're giving a lot of cases, you need to discover the pattern. In fact, you need to discover the formula. You need to discover the formula. So you need to learn how to explore. You need to learn the ability to look at a lot of data, be able to see patterns in it. So those are two very important things. Now, I want to give you a very simple example to illustrate that. So, at this point, if you have a piece of paper and pencil, follow through with it, right? A very simple math problem. The problem is called quickest to run. So giving any integer, right? Any integer, and you can do three things to this integer, right? If this integer is divisible by 3, you can divide by 3, right? So let's say 9. Well, 9 is divisible by 3. So you can say, okay, I divide 9 by 3, right? Or if it's divisible by 2, that means an even number. Well, you can divide by 2. Otherwise, you can always subtract 1 from it. So those are three things you can do to an integer. For example, I give you 11, right? And the question is, what is the smallest number of steps, right? So for example, I give you 9. So we say, okay, 9, I can divide by 3 and then divide by 3. I get to 1, right? So 2 steps, I get it to 1. So giving any integer, so I give you example 11. What is the smallest number step you can reduce to 1? Okay, so I give you a couple minutes to think about it, not a tricky question. So just trying to think about how you do it, right? And when I give this talk to, elementary school students, high school students, there's no problem. They know how to do it. So someone would say, okay, reduce 11 to 1, right? So here, so one guy would say, okay, I got it, right? So first 11 minus 1 get 10, right? So, and then 10 divided by 2 equal to 5, right? And 5 is, the 10 because 10 is divisible by 2, right? and 10 is divided by 5. And then 5, obviously you can subtract 1 and get to 4. 4 divided by 2 equal to 2. 2 divided by 2, this step. Okay, so you got 5 steps, right? So someone will come up with that. Now, if you come up with that, that's great. But you need to think about it. So just think a little bit. How do you get to that? Why do you decide to subtract 1 from 10, right? And then more importantly, can you come up with a better solution, right? Is that a smaller number of steps, right? So while this girl says, yep, she has a better one. So 11 subtract 1 equal to 9, right? 9 subtract is equal to 10. 10 subtract 1 equal to 9, right? And 9 you could divide by 3 equal to 3. 3 divided by, okay, she actually was able to get it to 4 step, right? So either one. So obviously 4 step is the right solution. But either way, I'm sure that you or even your child can find a solution like this, right? Either one solution. Obviously, hopefully the right solution. But the challenge is that, can you explain, right? Can you teach this to someone else, right? Or let's say you are a parent, right? And now say, okay, you say, okay, I can do this. But the challenge, can you teach a way to your children, right? To your child, for them to do it. Obviously, you cannot just teach them 11, right? Because the child will need to go to take a test. During the test, it's not going to be 11. I'm not going to ask him to do 11. I'm going to maybe 21, maybe 125, maybe 911, right? So I give a different number for the kid to do. So think for a second. How would you teach what you know how to do, right? It seems no one, seems everybody, right, know how to do this problem, 11. But the challenge is, can you teach it? Can you figure out how you did it and be able to generalize it so that your solution, not only for just 11, right, but for all integer, and you're able to teach that to someone else, right? So again, just I want to pause for a moment for you just to think a little bit, spend a little bit, think about it. So you need to think, what did I do? Why did I subtract 1 to 11, right, when I get to 10? Now, should I divide 10 by 2, or should I do 10 by minus 1? What makes that decision? So the issue here is that you need to think about how you think. You need to think about how you solve this problem and the step involving solving it, right? And this is really the key of computational thinking, is that you need to be able to articulate, right? Not only be able to solve a problem, you need to explain how you solve it, right? So now, in light of time, I would just kind of quickly give you some answer, right? So one way would be, in fact, oh, I can just try all the possibility. In fact, that's a really common way for the computer to solve a problem, is that try it, because the computer is very fast, right? So giving a number, right? I first try to see if it's divisible by 2. If not, well, see if it's divisible by 3. If not, well, you can always subtract 1, right? So after you subtract 1, you get 10. But 10, you can actually divide by 1, divide by 2, or you can subtract by 1. So those are 2 possibilities, right? And then you can kind of move on and say, okay, so now you get to 9. Well, what can you do to 9? Well, you can subtract 1. You can also divide by 3, right? Now, if it's 5, you can only, subtract 1. So you just kind of try all the possibility and keep track of it. So that would be one way of doing it, right? In fact, I challenge the parents, can you come up with another way to do it, right? So this is known, this is actually in computer science, it's known as search, right? Search. Now, search is a powerful way, but it can be quite time consuming. So a challenge problem for the parents, that can you, or even for the students, whoever is attending this workshop, can you come up with a more efficient way to solve this problem, right? So I'll skip that. So once you kind of figure that out, and you can write a program for it. So you can say, you can kind of write a program for it. In fact, you write a pseudocode, right? Kind of explain what it is, and then you write, so this is kind of, and then you can write a program for it. So if you look at kind of just quickly the step involved, right? So, in the first step is that you solving a specific case of problem, right? And then you think about, how did I do it? Can I generalize it, right? Can I generalize it into like a solution that I can explain, to your sibling, well, if you're student, to your siblings, or your parents, explain to your children how to do it. And then convert that into algorithm, right? So either pseudocode or you can write a little flow chart, right? This is called algorithm design. And finally, you code it. You change it to program. Now, traditionally, in school, you learn how to do that. You learn how to solve problems. In coding school, you learn how to code it, right? How to code it. But in fact, connecting, you know how to do a case to you can code it. There's two steps that's missing in the middle, right? This two step, in fact, is the core of computational thinking. One is that you need to be able to formulate the problem, right, in a way that you can describe the solution to somebody, and then you design the algorithm that kind of can take that solution into a way that you can teach your computer, right? So, and that is really the focus of computational thinking. So go back to this slide here, right? So what is computational thinking, right? So you do the abstraction, decomposition. It's really this part, right? Decomposition, decomposing a problem into smaller problem, and or abstracting a problem, right, into something that you could represent as by numbers, by variables. Those are really fundamental computer science, right? So those two things. And Henry will talk a little bit about it in his class. How do you teach that? And then the other two things is that how do you generalize, right? That's what I just described, right? And how do you design the algorithm? So these two things are unique. These two things on the bottom are unique to computational thinking. So now the question is that you realize, okay, you say, okay, that's really important. You know, I want to learn computational thinking. I want to learn computer science. I want to, you know, or you want your children to learn, right? But the challenge is that, how do you do that, right? And unfortunately, to a lot of children, computer science, in fact, to a lot of parents, right, even computer science is a pretty abstract thing. It's to do with data structure, it deal with loops, conditional functions, right? All those things sounded abstract, and it is in fact abstract, right? And you as a parent, and this is not unique to computer science, any subject, if you really want the student to learn, you need to engage them, right? They need to pay attention. They need to pay attention first, right? So what are the things that really truly engage students? Well, interaction and play. You know, it doesn't have to be game like the computer game, right? You definitely see those kids are really engaged in playing computing. It could be just regular game, right? Regular game. Visual, pictures, videos, sound, music, multi-sensory type of thing, engage students, right? Achievement and accomplishment. Basically, the reason why a lot of students get turned off by learning purely coding, they don't really, a lot like for example, that student that the parents sent me the email. The student, I talked to the student, he said, I don't really know why I learned this, why I learned Python, why I learned C++, why I learned this thing. It's really, they need to learn this. Learning a language should be a byproduct of they want to do something, right? Oh, I want to make a game. Oh, I need to learn this thing to make the game. So applying what they learn, in fact, it's driven what they want to do, you know, motivated by what they want to do and then learning it, right? So achievement, accomplishment, using what they learn to actually do something they're happy with. And obviously creative problem solving, not just memorizing things. So those are the key feature, I believe. It's just in general, when you want to engage the student to learn, right? It turns out, right, you know, I don't think any parents would argue with me that, you know, children like to play games, right? So in fact, all the thing that makes game attractive to play, they are the key feature that makes game the perfect medium for learning. It's for learning how to program, right? It's exactly the same thing. So, and the reason why a lot of kids like to play game, well, it's the visual, right? It's kind of fun to just, you know, fun to just watch, right? It's the interaction. You get immediate visual feedback. You press a key, right? You press a key while the character is running, jumping. You press a key, the Flappy Bird is going up and down, right? And the feedback's immediate. You do the wrong thing, well, you know, the Flappy Bird would hit the bar and it's die, right? So the immediate visual feedback, right, makes, if you can, you know, obviously you get that when you play the game, but you actually get the same thing when you actually write a code to make the game. the feedback also immediate. And in fact, you make the game a little bit and you play it and you see, oh, well, this is wrong, right? So all those the visual feedback, the immediate feedback would help to engage student, right? To keep their attention, and also the visual aspect connects rather abstract concept. I'm going to go into a little bit more detail in a few slides. Make it more tangible. Make it more tangible. So here, so if you look at traditional environment or learning how to make, learning Python, right? You write the code and you print out a bunch of number out here, right? So because those are output, but so this is using Pygame, right? So it literally, this I'm writing this game that's a simple version of the Space Invader. So a list, right? A list or an array or two-dimensional array would map into graphics. Say, oh, I want to have one alien. That's great. So you have a variable. Oh, I want to have one row of aliens, right? Say, oh, now I understand why I need to have a list, right? And why I need to have a loop to generate that. And then if you also have multiple layers, right? Multiple layers of alien, now you say, oh, I need to put a loop inside a loop. So the graphic makes, the abstract much more intuitive, not only more fun to do, but much more intuitive. So I think that's really the fundamental part of why game is a perfect medium. But a lot of parents think, oh, game is just for play, right? It's something you have fun with. But in fact, game is probably one of the most sophisticated software that involving multiple disciplinary in computer science. So I spent 20 years providing AI technology game companies, so I know what is involved in a game. In fact, a game is possibly one of the most sophisticated software. Now, long time ago, making those classic game, a couple of people can do it, and you can do it, like $10,000, $20,000. Now, some of what they call the AAA title takes $100 million and several $100 million to do, right? But more importantly, it actually involving multiple area of computer science, from simulation to computer graphic, user interface, a lot of AI involved, for the game character, user interface, user experience, right? And also the sound and music and sound effect, a lot of different things. So it's actually a multidisciplinary effort to build a game, even a very simple game. And also, if you look at the games, right? So remember, the focus of computational thinking is using the computer to do problem solving. At every single step of making a game, the students are facing many problems. In fact, sometimes the problem is big. They need to kind of divide it into smaller problems. So here are some of the problem that I just outlined a little bit, and Henry is going to, when he give you a demo of a simple game that the student will learn, he will actually break into a little bit more detail. So controlling a character, checking the character, what we call collision detection, where you're shooting a plane. Well, how do you know that the bullet hit the plane, right? What we call collision checking, obviously creating AI for the characters. Like Pac-Man has actually very interesting AI, even a very simple game. So if you look at every single step in making a game involving the student to formulate the problem they need to do and be able to solve it. Sometimes they have to break a problem into smaller problems and then solve it. And also, beyond just the programming, as you know, game has a lot of design, right? Whether you design a level, design a character, it's really a perfect way, a great way to encourage students to think, the creativity, and also, very important part, also design thinking, right? Whether you're designing a level or designing a character. So, I'm going to just, so obviously, there's all those reasons. And I want to use two of the classes that I think Henry teaching, and actually one old class and one new class, and I'll pass to Henry to explain a little bit of that. So one of the classes he had been teaching for many years now is learning Python and computational thinking by making game using a library called Pygame. And the new class actually using a platform that is a friend that created by a friend of Huayi and myself. This is called Scratch GPT. And this is an innovative way of teaching younger kids how to program. So I'm going to pass to Henry as Huayi said. So he started. He's still a college student, but he started teaching when he's very young. Here's some of the picture. He's teaching robot, and now teaching many classes in programming AI. So I let him to take over Henry, do you want to can you share the screen or?
Yeah, well,
Okay.
could you keep sharing for a little bit? Just leave it on the last screen. Could you
Oh, so I keep this
um
sharing. Okay, hold on a
just
second.
for a little bit. I'm gonna talk a little bit and then I'll start sharing after.
Okay, hold on. Let me see here.
So
Here. Yep.
yeah. Yeah, so hello, nice to meet you all. I'm Henry. I'm going to be talking about these two classes that I'm going to be offering. Also, maybe if there's a little extra time, I can show a demo of something fun to look forward to for like a future class. But these are the two classes I'm going to be teaching this coming spring semester. There's two. There's the Intro Python using Pygames or with Pygame, and then there's also Learning AI and Programming with Scratch GPT. I'm going to talk about the Intro Python first. It's a class I've taught a bunch, and I'll show you a few demos, a few examples. But first, I'll really quickly talk about what the class is. The class is a intro class, so any student can take it if you have done any block code before or any if you've done no programming before, you can take this class. We will go over a bunch of topics that are essential to programming. You might have heard of some of them, maybe not some of them. Variables, something called conditional statements, so like if else, things like that. Loops, lists, functions, all these types of things. And then the whole focus of the game is to learn these things to be able to apply them to creating a game. So I'll start sharing my screen so you can stop sharing if you like. I will share with you a few examples of what this might look like. So what I'm sharing with you here is my computer screen. It has a platform called, or an app called a PyCharm. This is just somewhere where you program Python. So this is just, don't worry too much about that. But what I'm trying to show you here is the structure for the class. It is a 12-week class where half of it is learning Python. So you spend 6 weeks learning Python, 6 weeks creating a game. I'll show you one example. The structure of the class is you learn some Python and then you create a project using that Python. So this project here I'm showing you as a demo is a password generating project. So we learn how to create a password. How it works is it prompts the user, how long do you want your password to be? I can choose maybe I want my password to be 12 characters, and it will print out this random password for you. So it's a mix of capital letters, lowercase letters, and numbers. So this is just one example of a project. There's a bunch of other projects that we do. So that's an example of the first 6 weeks. I do want to show you one other project that I thought was pretty fun. Was a tic-tac-toe. It says with functions here. So it tells you to pick a spot from 1 to 9. 1 being top left, 9 being bottom right. So I'll choose maybe 5. So you can see here, I got the position in the middle for X, and then the computer randomly picked a spot. So this computer, this is an example of a really, really simple AI. It picks a spot that isn't picked already. You could develop a more intelligent artificial intelligence for this or better AI to choose strategic spots to try to win, but this one's really, really simple. It just chooses one of the random ones that are open, and I can choose 2. Okay, it got lucky. It blocked me there. I'll do 1. Oh, it got lucky again and blocked me. And then, but I have a spot open up here, 3, and then I won. So that's another example of a project that we can make for that class. And then the final thing I want to show you for Intro Python is the game section. So the final 6 weeks, kind of the build up to the end of the class is a large project. So for 6 weeks, we spend only on this one project, making this game. So this is a not fully complete, but kind of like 90% of the way version of the game. But this game is Snake. So I don't know if you guys have seen this. It's an older game, like a classic game, but basically you're this snakehead. You move around and you collect these apples that are on the ground, and your snake grows longer and longer. And this project, we can take a look, has examples of every single topic that we learn in the first 6 weeks. So I think that that's really important is using every single topic that we learn about in the first 6 weeks to illustrate like why we're learning these things. We use variables, we use loops, we use if statements, we use lists here and there. We use all these different types of examples to kind of show why we're learning these things. And I think that's really important. So that's the first intro Python class. And then could you share the slide one more time?
Yeah, so on. Let's see. Oops, sorry. Slide here. So the second, yeah.
Yeah. So that's the first one, intro Python. The second one is with the Scratch GPT. So um, I don't know if everyone's familiar with Scratch, but Scratch is a block-based coding platform. Basically, you don't have to learn a language. You just connect blocks together for the program to do things. So when I say you don't have to learn a language, you still kind of do have to learn a language. You have to learn how the blocks interact with each other, like what certain things do together. But you don't have to be super precise about the way you type. You don't have to be worried about like yeah, so the spellings of things, capitalizations, you don't have to worry about that as much. So it's a block-based coding platform. Um, but what I've found in the past, I've taught this class for many years, in particular game design in Scratch. And the biggest issue I found before is with newer programmers, people who just start out on Scratch, is that a lot of time is wasted in like searching for blocks, dragging blocks, accidentally not connecting them properly, things like that. A lot of time is spent just doing that. I would think that maybe if I had to guess, maybe like more than 50% of the class is just spent troubleshooting and searching and things like that. So, and in my opinion, that's a really, really big time sink, like a waste of time, where you could be spent, that time could be spent learning, like my dad was talking about, a lot of computational thinking ideas where you don't need to be spent like dragging blocks. So that's where this AI platform comes in called Stacks. Stacks, what it does is you can prompt the AI and it will generate the code for you. Um, and so I wanted to say a couple things about this. I think it can kind of sound like you wouldn't learn a whole lot if the AI is the one writing the code for you. But I think and while I think that could be true, that I think a lot of people could take advantage of the AI without learning. I think that the focus of the class is not in just generating the code. The focus of the class is how to think about solving problems. I'll show you an example where you can prompt the AI to do something, but it might not do exactly what you want it to do without being very specific and breaking down a problem into multiple steps. We'll see an example of that. And the second thing is evaluating the code and being able to tell what each portion of the code is doing. I think this skill is really, really important in computer science. I think, like for me, for any programmer, a lot of your time is spent searching how to do something and trying to read somebody else's code, or people who are working on a team for programming, you need to be able to interpret other people's code to be able to work on a project together. So I think these skills are really, really important. And yeah, we'll take a look at the platform. So let me share my screen again. Um, okay. So this is Stacks. It looks a lot like Scratch if anyone has used Scratch before. The one difference is the character so this is just a fresh project. The character you get, it's not the Scratch cat, it's this dog. And then also there is this window here. So this window here is the prompt window, where you can prompt the AI to do different things. So I'll just give you a really quick example. I'm going to prompt this character to, let's say, I'm going to prompt him to move 5 steps to the right. Something like that. Just something really simple. Move 5 steps to the right. I prompt it by clicking the arrow. And it generates this code for me. So while this was kind of slow because I could do this pretty fast, right? For a new student, they might not know where green flag clicked is. They would have to search one at a time, find the block, and then, oh, I don't know where move 5 steps is. Have to find this block as well, right? So it might take a while for a new student. And with more and more complicated code, that time just gets longer and longer and longer. So I think that's a huge advantage to this. And then if we take a look, it moves 5 steps to the right, right? Exactly what I asked it to do. I'm going to show you that's just a quick demo on how this works. I want to show you what I was talking about earlier about you can't really prompt this to do these huge projects with really simple commands. So I want to give you an example. I think this is really impressive already, but I'm just going to prompt this to make Flappy Bird. So to make the whole game Flappy Bird, I'm going to prompt it to do this. It might take a little bit. Let's see. Yeah, so it might take a little bit longer to do this than there we go. Okay. So not too long. And you can see way more code, right? So as you can see, as the commands get longer and longer, what it's trying to do get longer and longer. This saves me so much time. And I'll get to it later, but I think a huge focus of the class is going to be you get this code, but you need to evaluate what each portion does, explain what this block does, what this block does, what each part does. And also there's going to be issues, right? This is not going to always work out exactly how you want it to. So let's take a look at what's wrong with this one. So yeah, I'll go full screen for this. So this should be Flappy Bird, but if we take a look, this is not exactly what Flappy Bird is like, right? First of all, one big issue is I noticed that each of these these are not pipes, these are dogs. Also, it seems like the random area is pretty small, and these it seems like I can just stay up here the whole time, right? So there's a bunch of issues with this project, and this is not exactly what I want, right? So it did a really good job, in my opinion, creating this even. And I can see if I crash into one of these, the game. Oh, so that doesn't even work, right? So there's a bunch of issues. Oh, I can see here the reason there's an issue here. It says touching edge and touching edge, so it's only if it's hitting the edge of the screen, not if it's touching yeah, so this doesn't work. So there's a lot of issues with this. And if I wanted to make this project work, I would have to break it down into a lot of steps. So that's one of the things my dad was mentioning about computational thinking, which is really, really important, in my opinion, is the decomposition portion, which is breaking down a large task into a bunch of smaller tasks. So I'll just give you kind of like my initial thoughts on needing to create this game. I would think about it as not just making the whole game. I would think about it as making the bird, making the pipes, making backgrounds, making all these things individually. And then I would need to think about how do I make the bird jump? So that they actually did a really good job on the jump code. It's this section here, the jump code. So I would maybe prompt let me see. Maybe prompt one portion at a time. So let me just reload this one. So I'll just give you one example. I'll prompt it one time, one part at a time. So I'm going to say make my character uh, jump, something like that. So this is one portion of the code, and then another portion could be I need to make my pipes move from left or from the right side of the screen to the left side of the screen. Okay, this is not quite what I want. Let me try one more time. Do this a little bit better. Okay, there we go. So let's see. So every time, okay. This one's not too good either. Let me try one more time. Yeah, so the idea is breaking the project down into smaller and smaller portions and then evaluating the code. Okay, there's some issues with this. Yeah, and I would actually like for the class, I would not have this as a prompt. As you can see, it's not consistent enough. I would break this problem down into smaller portions, right? Like, how do I make my character jump? Uh, so I would break that problem down into smaller and smaller chunks as well. Let's see if this is okay. This is still not great, but we can take a look at this in a second. So and then so a big portion of the class would be this code does not work super well, right? It's not moving very smoothly. It's moving one little part at a time, and then yeah, this is not great. So that a whole portion of the class would be to look at this code, figuring out what each of these things are, and how can I like change this code to make it better. So I'll just give you like one really simple example for this one. I don't want to get too complicated. Is I don't want to move every time I click green flag, right? So I can see, okay, the reason why this code moves every time I press green flag is because of this block right here when green flag clicked. So I want to edit my code. So I can go to this code editing section and say, can you make it so that my character jumps when I press space instead of green flag? I'll run that. And then now you can see it gets replaced. Now I press space. Okay, and then there's another issue. It jumps forward for some reason. So I'll have to figure out what the reason for that is as well. Or it's this block right here. Let me see if I can prompt it to get rid of that. Make it so my character doesn't move forward during. See if this fixed it. Yeah, there we go. So you can see it's not as simple as just prompting the AI to do something. You need to figure out what the problems are, how to fix them, and then more problems come up and you need to fix those as well. And breaking down the whole project into smaller and smaller chunks. And so the advantage to this is a lot less time spent creating, like dragging these blocks of code, and a lot more time spent on learning what the solutions to problems are, the way to think about problems. And also, I think even a larger portion is reading the code and being able to understand what the AI had told, like put out as the code. So yeah, that's pretty much it for that. I think that kind of wraps up my section. Does anybody have any questions about anything? Let me see. Yeah. Yeah. So that's kind of it for my section. Does anybody have any questions?
So,
Any?
Henry, let me just kind of come back to
Sure.
that, and then the parents can ask questions, right? So I just want to kind of emphasize what, the thing that so, with this uh uh with this prompt way of, this is kind of really a brand new way of learning programming, right? Before obviously Scratch is very popular, but in Henry's teaching and myself teaching is that kids spend a lot of time memorizing a block, searching for it, and kind of even dragging it and matching it, right? So, but with even you can talk, with the prompt engineer, you can talk in English, but you notice that you still need to talk in a way that the computer or the AI can understand it. So the focus has transformed from memorizing a block and using a block to focus on the problem solving, the logic, the reasoning, right? Behind the problem. How do you break the problem into smaller ones? So if I tell them to do this big thing, it didn't do it right, or maybe I can just explain a little bit into smaller step. But also the side benefit of this, right, using stacks is that now, obviously if you're working or you're college students or even high school students, using, you're using open ChatGPT for different things. In fact, using the large language model in programming is ideal because the possibility is a program, right, with the graphic is much richer environment than outputting into text, right, a paragraph or whatever. So it turns out, linking the large language model with programming allows younger students to start getting a sense of what AI is, right, experiencing what AI can do and start you know using it, right, the same way that professional programmer using copilots and other things to help programming. So as Henry said, the classes for the Python with PyGames for student who has a little bit background in Scratch programming. You're learning Python much more structured. The AI and for with the Scratch GPT is for younger students. I think there's obviously no perfect age, right? But I think we have students as young as second grade, before learning Scratch, but then turns out first, second grade, but turns out they spend a lot of time wasted remembering, searching for the block. But with this, I think they can actually focus on more on problem solving. So like Henry said, just any question from the parents or if there's students there.
Yeah, I had a question about how, so when you help the kids think through what their strategy is in commands that they give to ChatGPT or whatever you're calling it, or in any of your classes, do you have any, do you have them like draw it out and diagram it, or because it seems like it would be very fuzzy in their heads if there wasn't like some like structured way of articulating it. Like, do they write it down in paragraphs or in pictures or in like box and arrow diagrams? So
Henry, you want to take that?
Yeah, sure. Usually I try to have like a conversation with the whole class. So I don't oftentimes have students write down. I think it is a good idea. I think it's super helpful. I have noticed that sometimes it can be a little bit harder with the younger kids to get everyone to like fully participate unless it's like a conversation. So I try to just have a conversation with them about the ideas, and then usually I will write them down on my screen so everybody can see kind of like I'm trying to like I think there's a word I'm looking for, but like just a collaborative. Sometimes it's a diagram, sometimes it's like a list of things. Um, like an example is if we have one smaller portion of a game that we're trying to figure out a problem for, maybe there's five individual portions of that that we need to do, and I'll kind of ask for everybody's ideas on what those things that we need to do are, and then we'll break it down even more. So yeah, I guess it kind of is a little bit like a diagram. Does that kind of answer your question? Yeah.
Yeah, it's helpful. Thank you.
Yeah, so I just want to kind of just chime in for one thing. In fact, that's again where the graphic part comes in, right? The games, like the game is graphic. So try and errors, like the kid, they do something with the code, right? And maybe they don't understand what it is, or maybe they understood the wrong thing. But just running it, right? The running it. So let's say they make a mistake, like just Henry was prompting it, the code make a mistake. You can see right away. You see that the thing is not doing what you want, but you also see what it does, right? What it does. So in fact, you can almost think, I think sketching and visual user is very useful, right? For kid to understand, express things. But in fact, the graphic on the computer does that, right? Does that, because sketching, obviously you have to take time to sketch it, right? But so that's exactly what the game, the graphic brings, that it allows the kid kind of see and to express, right? What they have, and to express and to experience, to experiment, right? To see, oh, I modified this, and now this does different thing. So I think that connection, in fact, it's okay for them to make mistake. It's okay because in fact, there's really no such thing called mistake, because you actually see what the code does, right? Obviously, you want to organize and write the code that does a certain thing, but every time you write the code, you see what it does. So the graphic actually kind of does on this computer screen kind of serve the purpose of you sketching on paper.
Thank you.
Yep. Any other questions?
Hello. I have two questions.
Uh-huh.
Yeah, can you hear me?
Yes.
Okay. So I'm from mainland China, and I wonder if you have any kids, previous kids from mainland China, and I want to know if Stacks is available for the kids after their class, for the practicing purpose. And
Yeah, so
if
let me,
it is,
so Henry, let me ask, so you want me to answer a question first, or you ask both questions?
oh, I have like two questions. The first one is if Stacks is accessible from mainland China. As you know, there might be some kind of block, so we can access certain websites in here. And I want to know if Stacks is available to the students, registered students, after their class, just for the practicing purpose,
The answer is yes to both. Yeah.
Oh, I just typed in the website on the chat box. You can try to see if it's accessible from China.
Okay, and there is another thing, another problem. My kids, Abby, she's studying English like from she's a baby, but she's not quite, here in China, her English is not so well. Maybe speaking, but in typing, in writing, I'm not sure if she could. She's 9 years old now. I'm not sure if she could write the proper sentence to prompt
Henry, you
the
want to
Yeah.
text.
because Henry actually taught some student from China. I mean, in the so he has some experience.
I'll say two things about it. My Chinese is not great. I can't speak it very well, but I can understand quite a bit. So if there's ever a time where she can't express something, she can try to speak it in Chinese, and I can. That's just one thing. The other thing is that I didn't show it. Let me actually show it really quick. I think it's a pretty cool tool on Stacks. You can actually speak to the AI and it can interpret what you're saying. So let me do a
Can
little
you
bit
show
of
the
a
screen?
yeah. Give me a second. Okay, so I'm going to click this mic and then I'm going to give it a prompt. So let's see. Let me think about something to say first. So make my character jump. So I say it using the mic tool and then it prints out here. Sometimes it's not perfect. It works pretty well. If your mic's not super great or if there's like a lot of audio in the background, it might not be perfect. So you can just edit this text as well after, but you can just run this and it will spit out the code. So if typing is like a big issue, I have had a few students that just haven't typed a whole lot in the past. So if it takes a long time to type, they can use this tool. I think it's a really great tool. Yeah. So does that kind of answer your question?
Yeah, one more thing, right? You can actually talk to in Chinese. So
Oh, I didn't know that.
I talk to it in Chinese, and also I have co colleagues and coworkers in China. They're talking to Chinese. That's the great thing about large language model is that it actually you can use different languages. Yes. But I want to
Oh,
make one more comment on that because Henry
mm,
taught some student from China, and the students, his English is okay. He's actually from a public school, right? So, but it's not very. So when he first took the class, he was very quiet, and he didn't say much. And Henry's a little worried, maybe he doesn't understand. But it turns out that, um, in fact, what the parent discovered after the class is that it's a great way. In fact, computer science, I believe, is the best subject for a student um, to do it in, if they want to practice to take a class in native English environment, right? English environment. Computer
yeah,
science is the perfect class to do it. The reason why is that, let's say if you take a history class or a anthropology class, well, you need to know English really well, right? Because a lot of vocabulary, if you don't understand the vocabulary, you have trouble understanding it.
yeah,
But computer science, but if you take a math class, well, it's too easy, right? It's nothing, it's just all symbol. But computer, particularly a computer class that you actually make games. There's a story, there's some characters, and it's right in the middle, and the student can practice English at the same time, it's not too challenging, right? All the words are not particularly you can actually if you don't understand it, you can just kind of take the code, right? And then that's also where the graphic part, the gaming part also makes it easier because you can see it, right? If it doesn't work, it shows up doesn't work. So I think that's kind of our experience in teaching um, Chinese student, right? But in the classes in English.
Yeah, that's actually
yeah,
what we built Bilin Academy is for, to provide content and language integrated learning experience. So the kids can explore the subject that they like and while learning and practice their second language.
Yeah, so perfect.
yeah. Okay, thank you. Thank you for answering my questions.
Yeah. Any other questions? Yeah. If no question, we can wrap it up at today's meeting. I want to send a heartfelt thank you for our amazing speaker, David Zhu and Henry Zhu. And thanks for sharing your insights on computational thinking with us. And especially for Henry, demoing so many interesting games, how to make them and demoing how to use Stack. And yeah, be free to reach out if you're interested in Henry Zhu's class. We will be organizing a trial class soon. And yeah, stay tuned for more events like this. And I hope everybody has a good evening. And Yeah.
So
Thank
are
you.
you going to
Oh.
send an email with like the dates and the pricing and when they start, the times?
Yeah, we're gonna discuss more in details. And yeah, when everything's ready, we'll send out notification and date and time and stuff like that.
Cool. Thank you very much.
Thank
Really
you.
appreciate the
you.
effort that you put into presenting. It was really interesting.
Yeah, thank you.
Yeah. I guess that's all. Thanks everyone, and I hope everyone has a good night.